It's a paradox to me that that technology still exists, but it still does. And it processes trillions of dollars a day. It's extremely reliable. It's been ripe for disruption 3 or 4, 5 times between 99 and today, but it still continues to exist and out-exist executives, strategy decks. It still keeps going. And I'm fascinated by that. I'm fascinated by that longevity of technology.
It's crazy. It's a function of the degree to which a lot of software before cloud, was really unstandardized. And so deployment and your application were really quite tied together, and the ability to customize your system, versus use like off-the-shelf frameworks and practices, was a much bigger thing pre the internet age. So these things are like basically massively customized, and that makes them impossible to move. In the mindsets of many not just banks, airlines, retail, all sorts of companies that are still running these systems. In nearly all cases, we are seeing customers interested in moving to real-time architectures where that can be streamed through Kafka, and the reconciliation can happen almost instantly. And that allows you obviously to deliver a better customer experience as a consumer. Checking my banking app, I no longer see my credit limit update, once every 2 days. It's now like, the second I actually make a transaction. So it's things like that these new architectures enable.
The monthly cycle is based on the moon. It's based on Neolithic or historical or geological functions. Have a financial month, the quarter end. These, the date, why do we still operate our financial systems on what is pre-modern time schedules when we operate within this 24/7 real-time digital environment? Are you professing this abstraction, a true abstraction from the physical world? Because we still run on schedules built on the physical world. Are we ready to let go of that and move to something completely abstracted from the physical world?
But essentially, there are 2 ways to modernize legacy applications. The first is we go from legacy language, so let's say COBOL, to the modern language directly, with no kind of intermediary representation. And the other way you can do it is go legacy language to English, or just any natural language. Basically describe all of the programs as in terms of a bit like a black box, like what goes in, what goes out, what are the key processing functions, and then based on that synthesize a new application based on the natural language description. And what we're finding is actually that second route is getting a lot of traction with customers. We offer both, and we, for certain projects with COBOL, it actually might be preferable to do the first, because these systems are subsystems of subsystems, and you don't really want to change any of the functionality. But for especially online systems, for example, it's very helpful to be able to explain what this does to somebody who's actually used that application. So if it's a risk and compliance platform, then you might bring in some of the users of that platform, show them the English, the natural language descriptions, and ask them, can you actually add
Baseline.
The baseline is designed to create an emotional response.
I've seen things you won't believe.
More human than human. Make you question everything.
So what should you optimize for as an early stage founder when you're trying to maximize your chances of success? Well, you want to surround yourself by great founders. Founders are infinitely more useful than investors for helping you as a founder navigate all the challenges that come with finding product market fit, hiring, things like that. Because these people, they just have, I don't know, they're in market, they are feeling the same things that you're feeling because they're going through it. And if that's true, that founders, if you're trying to find a group of people to help you build your company, and founders are more useful than investors, then what greater group of founders is there than the YC network? That's the real strength of YC. So that's why I tell people to get into YC.
And do you still benefit from that network now?
Yeah, massively. Yeah, almost every, I don't know, so many interactions, so many of the companies you meet, especially in AI, applied AI, are either YC alumni or are current YC companies. It comes up everywhere. Yeah, it's massive.
I mean, the AI banner for startups now, I think, is it confuses the market.
Yeah.
And it certainly confuses potential buyers.
Yeah.
I've just been kind of reflecting on this idea that there was this profound moment where ChatGPT made content marketing, website design, so accessible to everybody.
Yeah.
To everybody. So anybody with an idea immediately was a founder.
Yeah.
Because previous to that, people had ideas and they never really executed on them because it took time and effort and money and investment and commitment, reputational risk. People had to actually say, I'm going to do it. Whereas now, 20 minutes in ChatGPT, you can create a startup, a brand, an elevator pitch, a one-liner, a sprint development plan, and all of a sudden you're a founder, right? So
yeah.
I had this moment where I thought ChatGPT and other generative AI solutions, consumer generative AI solutions, were this panacea of accessibility, giving people a voice that they'd never had before. And it's done two things. I think there's a cruel irony because there's so much noise in the market and so many more founders and so many people doing so much stuff. The buyers are so confused and almost, it's the paradox of choice. There's too much choice. They're actually rolling back to the traditional, trusted technology brands. When are you going to have this feature function? When are you going to have this capability? Then obviously there's the LLM companies who are slowly but surely rolling out features and functions that just swallow up these external wrapper companies. So I think it's a really interesting, but I don't know, quite risky time to be a founder certainly in the AI space.
I don't think anything that's happening now with regard to the platform application dynamic is anything we haven't seen before, right? So you could use the App Store as an example where Apple rolls out an App Store and then there's a load of apps initially. Let's take the most basic example, the flashlight app that was on the App Store back in the day. And at some point that just becomes part of the platform, right? And there's no place for third parties to build those types of applications. They've been absorbed. But it took a few years for that to happen, for Apple to build a flashlight app. I think what we're seeing with AI is kind of the same movement of the platforms expanding their market share by moving into where these kind of third parties that a lot of YC startups are operating, but it's just happened years ahead of what happened with the App Store and things like that. But actually the dynamics have been seen before. So what therefore do we learn from that? If that's true, if things are kind of playing out similarly to the App Store, well, there are always opportunities around the edges, right? So, for example, a lot of the features that are being absorbed into the ChatGPT or Claude AI text box are consumer-facing features. And when you go to the enterprise, there's a whole load of things that need to happen that actually can't be solved with software, like sales. Sales is a process. If you're doing something like what we do, which is tech modernization, you've got to help a customer understand they have a problem, guide them on how to fix that problem, do the architecture, do the security, all of these kind of moving parts. There's a whole integration piece around what the AI is doing, which is, basically the grunt work. And so there's always going to be a space, especially in enterprise, but there will be bits around the edges that that the model companies won't be interested in doing because they're, human intensive, or there's a big sales process or whatever it is. Or it'll take them 5 to 10 years. I mean, a lot of this is kind of like arbitrage as well, right? Like the opportunity for the next 2 years is not necessarily the same as the opportunity from years 2 to 5. And you might look at some of these startups, and I don't want to be specific, but certain coding startups, and say, well, we've had a good run, and this is like the perfect time to sell this business before we get absolutely fucked by OpenAI, right? But the same is true from now. There are things that you can do for the next 2 years that that OpenAI is not going to touch, that could still get to multi-billion-dollar.
How far will OpenAI go?
I would say, I wouldn't say that anything is off limits.
NVIDIA scale.
It's not a question of, but it's the wrong question. It's not what is in scope for OpenAI to work on. It's when will they work on it? What is a 10-year from today thing that they'll work on, and what is a 2-year from today? And you just got to build for the opportunity in that window of opportunity, right?
I'm fascinated by what's happening because, and I'm very excited to talk a little bit about your current motion with Bloop and that modernisation, of centralisation of the mainframe. There's one question that I'm struggling with to answer, and I'd love your take on it. Is that since around the 2016 time, we just saw the mega growth of SaaS, and it was off the back of people realizing multi-tenant hyperscaling cloud architecture is just a great business model.
Yeah,
because you can essentially in software build it once, sell to many.
Yeah,
it's delivered from the cloud or delivered as a service, so you don't even have to have upgrades and people on premises and all of that stuff. It's just a great business model. And companies like Salesforce, for example, absolutely pioneered and perfected the delivery of quite a niche value proposition as SaaS and grew outwards, and have commercialized that phenomenally well.
Yeah.
And when I look at the rapid emergence of augmentation technology, especially around coding and marketing and building, the SaaS world, it's no longer, anybody can kind of build anything now. Then you get into intellectual property and patents and that. Let's just leave IP protection for a second. Yeah. If anybody can build anything themselves, why would you buy it off somebody else when you know they're getting 80% margin on it?
Yeah.
So like I have seen, and I'm interested, there's that, we all know that enterprises want to focus on what they do and they don't want to build stuff. And we don't want to say everybody's a software company again. I've heard that story so many times over 20 years. Yeah. But like what we are seeing, certainly off the back of what I would say is the Palantir model, are these like co-build, co-create services / AI / customer building something together. Like, is that a thing, do you think? How is that going to play out over the next 5 years?
Yeah, so...
Can you sense that tension in the market?
So just to re-articulate the tension, so the tension here is that previously you would have bought something, but now it's so easy to make something that you're no longer going to buy something off the shelf. You're going to have like there's going to be more of a move to personalized solutions. Is that the... Yeah, I think we're already seeing that at a consumer level with, products like Lovable that allow you to create, sort of CRUD apps in flexible ways. I mean, it's kind of amazing how many applications are just like a database data in and out, and some very lightweight processing on top of that. It's like 99% of the apps that the average consumer uses. But this is also something that has kind of been happening for a while. You know, you had like Retool and applications like that in the pre-AI era, where people were already able to kind of drag and drop, create, you know, things on, you know, quite complicated apps on top of essentially CRMs. So I think this is just an extension of that. Companies have always wanted these customized platforms, and this is really an accelerant to that. And for people that don't care and don't, you know, and are happy to, you know, because often, like, the reason you buy HR software is like, one, so that you have it, but two, so that you actually like, I don't even know what HR is as a startup, but if I buy this package of software, it's just got all the buttons in the right order, and so I now have HR essentially, right? So there is a use case for people to still have an opinionated way about solving problems, and you can just mix and match.
It's a little bit like outsourcing accountability to the SaaS provider, and where the company's going to want to take that accountability. So there's like a business accountability challenge that comes with owning what you're building.
Yes, yeah, definitely. We definitely see that with, you know, with the legacy code stuff, is that people are, I mean, ultimately the buck has to stop with the humans, and no matter what you build, it still has to go through like review, and somebody has to sign that off, and basically, you know, it's the person that's getting fired if the system goes online and then immediately falls over, right? So,
you know, when I originally heard about what you're doing, I think I said this to you on your call. I've met you 4 times before over the last 20 years. And I wanted to, you know, when you look at traditional enterprise core systems, especially the financial services sector, you know, you're dealing with centralized monolithic architectures, highly proprietary, that go back pre-internet. These things existed before the internet. In fact, I remember in 1999 plugging the internet into a DB2 database on a mainframe.
there you go.
And disconnecting the cable that went to the VT100 terminal in the branch, and connecting it to middleware that managed to take messages and turn it into HTTP service requests. And between then and now, everybody is, and I know all the mainframe development team, and I know all the people who sell it, and all the people in the banks. Like, it's a paradox to me that technology still exists, but it still does, and it processes trillions of dollars a day, an hour. It never, you know, it's extremely reliable. In some ways, I feel as though it's been ripe for disruption 3 or 4, 5 times between 99 and today, but it still continues to exist and out-exist executives, strategy decks, you know, customer eras. It still keeps going. And I'm fascinated by that. I'm fascinated by that longevity of technology.
Yeah, it's crazy. It's a function of the degree to which a lot of software before cloud, you know, was really unstandardized. And so deployment and your application were really quite tied together, and the ability to customize your system, you know, versus use like off-the-shelf frameworks and practices, was a much bigger thing pre the internet age, you know, where you might have more knowledge share because, you know, people are learning about things through the internet as well. And so, so these things are like basically massively customized, and that makes them impossible to move, you know, in the mindsets of many, not just banks, airlines, retail, all sorts of companies that are still running these systems. I would say the general sentiment of the market is this is too hard to do, but there are a few customers who kind of really believe that they can exit their mainframe in the next, you know, 7 years. And I think as we do more projects with some of those types of customers, the rest of the market will look around, and at some point they'll realize they're like one of the few remaining on the mainframe because everybody else has decided to move. And it's a mindset shift, you know, it takes it kind of starts slowly, but these banks are very sheepish. They look left, they look right, and they're like, are we benchmarking, the same as everybody else? And the tide is changing on mainframe. Today, you're completely right. Like, it is normal to have mainframe, but that is shifting and will continue to shift.
What's the benefit to an organization of moving from it, of shifting from it?
Yeah, I mean, the boring answer to that question is like cost, but the exciting one is innovation. So imagine you have a small and shrinking pool of talent that can manage your legacy systems. If you need to do anything like ship new customer experiences or build better tools for your staff to use, or to be honest, like this new emerging thing, which is like, okay, well, if there's AI involved and AI is going to wipe out, mid-level management, then we need to prepare our systems and our systems of record to be accessed by AI. If you want to do any of those things that are kind of in the innovation bucket of work, then it's much easier to do that when you're in a new language, because you can resource efficiently with plenty of developers that have just graduated that speak these languages. Your burden for DevOps is massively reduced. I mean, cloud, this is like similar to the kind of on-prem to cloud thing. Just going like mainframe to cloud is similar. It just simplifies the development lifecycle, so you can focus on the software and you don't really have to worry about the thing falling over. That's all an abstraction. So that's the real big opportunity cost to anyone that is not modernizing their legacy code today, is all of the great customer experiences, tools, etc., that they could be shipping that they're not because of the fact they're on the legacy system.
What type of tools are you seeing coming out of like microservices-based organizations that can't come out of the legacy data gravity monolith?
So what types of applications are people converting?
What fundamentally? I was just trying to get to what is the benefit of, what's the risk reward? What's the reward of moving to a modern architecture? Yeah. And that is shipping new cool applications and features. Okay, what are they?
Fine. Real time is a great one. So the mainframe paradigm is all around batch and online. Batch basically means something runs overnight or at the end of the month or at the end of the week. And it's normally a huge process. Maybe it takes all of the transactions for the day and then opens everybody's account and then kind of tallies up, what your credit limit or your balance is or something like that. And in nearly all cases, we are seeing customers interested in moving to real-time architectures where that can be streamed through Kafka and the reconciliation can happen almost instantly. And that allows you obviously to deliver a better customer experience as a consumer. Checking my banking app, I no longer see my credit limit update, once every 2 days. It's now like, the second I actually make a transaction. So it's things like that these new architectures enable.
Isn't it interesting? I mean, that's fascinating because when you think about it, the monthly cycle is based on the moon. It's based on Neolithic or historical or geological functions. Our financial month, the quarter end, these, the date, why do we still operate our financial systems on what is, I don't even know what word to use, but quite almost pre-modern time schedules, when we operate within this 24/7 real-time digital environment? We're still doing month end and quarter end for business. Now, obviously, you've got public markets and everything runs around the planets and time. Are you professing this abstraction, a true abstraction from the physical world? Because we still run on schedules built on the physical world. Are we ready to let go of that and move to something completely abstracted from the physical world?
That's a big question.
But that's the reality of what we're talking about here.
Yeah. Well,
why do we continue to allow our financial existence to be oriented around the physical world?
Yeah. Well, I guess
because to abstract from that
Yeah.
People are, we're not going to have foundations within the day and the night and the month.
Yeah. Look, I think humans crave schedule, right? So you have your weekday and your weekend, and you have Christmas that everybody works to, or most people work to in the UK, and these are like important because humans just naturally have that essay crisis moment, right, where they just get things done. As the urgency grows, the more closer you get, and so I guess as less work, well, as the work starts being done more and more by systems that don't care about that and work with high intensity at the start of the period of time and at the end of the period of time. I think you're probably right, like the notion of like work happening within a period of time starts to disappear. And it's just, these are my goals, get them done as quickly as physically possible, right? And
what will that mean for macro productivity? Because
Yeah.
to your point, like even the idea of payday, you get paid on, most people get paid on a monthly basis, and they operate their financial well-being to the monthly cycle. And there's loads of businesses around that to help people move months and this sort of thing. We're talking about financial cycles that operate in line with the very planetary, structure of the world. By moving away from those physically manifested boundaries that drive productivity on a month, on a quarter, on a year, what do we become?
Yeah. I don't think. Firstly, I don't know that it's a given that is all going to go away, right? Like we can end game this scenario, and maybe you get to a place where we're just all kind of sitting there on beanbags with no notion of time because everything's just happening and we're out of the picture. But I mean, the reality is this stuff is biological as well, and I don't think there's only a certain degree to which we can try and remove these boundaries before we just hit these caveman sort of desires to accomplish something in a given period of time. Without that, we probably lose the will to live.
So if you think about organizational productivity moving away from the batch process, the offline process, and moving to, how does productivity change by moving away from forced boundaries?
So things get done much quicker. Information that previously would have been available at the end of the quarter is available at any moment in time. At the point at which you're making decisions, that in turn probably means that you don't need as many people. The people that are making decisions who need the information are able to just access that at any moment without having a whole team of people kind of going and doing the work to figure that out and actually gather data. So, probably like much better, quicker decision making at a really abstract level.
Well, I mean, I'm thinking back now.
Yeah.
I used to hate the fact that capacity planning for batch workloads fundamentally meant that you had extremely low optimization rates over time.
Yeah.
Because you needed to manifest infrastructure for peak workload, like a big bang peak workload that meant for 29 days of the month, and I don't know whether this is still, I actually don't know whether this is still a relevant conversation, but it felt as though when you were capitalizing the acquisition of infrastructure, like storage, like compute, like network, which fundamentally changed to cloud, if the mainframe is still the same as this, I'm not, like, that you had to have a peak ability that for the rest of the month would either sit quiet or you'd look to purpose it into, parallel workloads, but not core. So like, that has gone. Is that still how it happens? Is that still how it works?
Yeah, no, it is, and that's exactly one of the reasons why I think organizations want to move to more real time. It's a simpler architecture. You are spreading the load over the entire period of time, and you're completely right. These batch processes dominate the conversation. Like, how do we optimize the MIPS? Because the billing is obviously much higher in that surge period. versus really thinking about all the other things. So those are the types of conversations that you just don't need to have as an engineering team once you make the switch. It's a
I
classic
mean,
example.
this has already happened with AI, and I've always been an infrastructure person, but I remember building infrastructure for MapReduce, Apache Hadoop, the big data era, where we were doing batch analytics to have some form of prescriptive insights to try and predict the future based on a 24-hour cycle of data or a weekly cycle, monthly cycle of data. The profound moment for AI, in my kind of layman perception, I'm here to learn, but was that moment where we moved from the idea of batch analytics to real-time prescriptive AI, and then the application against language and transformers and all of that architecture has massively accelerated consumption because you didn't have to put 8 questions in and wait till overnight to get the answers tomorrow morning. It came real. Is there a necessity for all of those core architectures essentially to follow what's happened in AI?
It's a good analogy. I mean, but the real breakthrough is just efficiency, right? With AI. I mean, the reason you can get a real-time response is because you can do a lot more inference in that period of time. And so I don't know how much that is the bottleneck really with like batch systems going to Kafka based. I think this is more just downstream of like, well, we have the internet, so all of these different systems are kind of networked. We have these new architectures like Kafka, which nobody really designed for in the first place. And the real thing that is going to enable you to go from A to B is the fact that the switching cost has gone, not to zero, but to a lot lower than where it was. These architectures have existed for a while.
So tell me, what does your roadmap look like at Bloop?
Yeah. So
tell me what
the master plan.
Yeah, I like the way you say that. It's got James Bond enemy energy.
Yeah, I think it's interesting. So this is something kind of, as a startup founder, I think you're told to have a 10-year vision. And I think at some point with AI, you sort of realize that your 10-year vision needs to be more like a kind of 2 or 3-year vision. And so the master plan really is to solve customers' problems that they experience today, and it's the intersection in the Venn diagram of that with what is OpenAI, Anthropic, Google not going to build in the next 3 years as well. They can build it in 4 years' time, but not in 3 years' time, and that's the safety sort of area that we think about. Now, that's obviously just the startup basics. From a customer perspective, we want to solve something that is a top 3 hair on fire problem for at least some customers in that segment. And we want to believe that by the process of us existing, more customers will decide that this is a hair on fire problem. So it's not an obvious opportunity for everyone. So this is where, to tie this back to legacy systems modernization, there's a subset of the market that cares about this and needs to do this in the next year, 2 years. And they have no alternative, but because the company's been acquired, the new CIO has come in and they're passionate about this, they get this, they're from the new cloud world, or they're bottlenecked. Their database is on a mainframe, they need to get some data lake in the cloud because of some sort of capacity issues that are actually causing a business problem. So step 1 is get started with all of them, and we're working with a bunch of great customers now that have this high urgency. Prove it out, get those first couple of logos and case studies, which is notoriously difficult with large financial institutions, but we're getting there. That will create the pressure on other companies to look at this. And the question that we always get in conversations with big banks, okay, cool, which other financial institutions are you doing this with? As soon as we can answer that effectively and publicly through delivery of these first few projects, we will be in a position to massively scale that out. So that takes you to legacy code within kind of mainframe technologies, and we're also addressing like legacy Windows applications, legacy databases as well now. That gives you a really front row seat into everything this organization is trying to do. So you get visibility on step one was get off COBOL and move to Java, but step two was actually do the Kafka thing that I was talking about. Or step three is like build that mobile app. And so you're in a great position because you've got the knowledge of what these businesses' problems are. You've proved yourself by doing the hardest part of that journey. And then you can move into all of the other maintenance, feature development, further refactoring that these organizations need to be doing. And we're already pushing through into some of those markets, especially with things like refactoring applications from monoliths to microservices and Kafka-based architectures as well.
I mean, I did, in my preparation for this, I did do some research, and many of the financial organizations, I think over 30, or certainly there's been over 30 outages on these core systems. Yeah. In recent history, I think in the last 24 months, based on what is termed legacy complexity. And what I was trying to work out is that legacy is complex because modern knowledge doesn't fit those architectures anymore. It's like the aperture of contemporary knowledge is always moving. So new things that we don't quite understand yet don't have the spotlight on them. They're a little bit in the twilight. And as we move forwards, more people get contemporary knowledge and they learn, they get excited. And as more knowledge becomes on it, we move into it. Yeah. But there's also this other aspect of legacy complexity increasing as that aperture moves away from traditional architectures. Is that happening?
I think a lot of the frustration that we hear with people that are operating these systems is related to personnel turnover. So, we're modernizing an application that was built in the 70s at the moment for a vendor of aviation software. And none of the team that are working on this from their side, the COBOL engineers, were around in the 70s, right? And to be honest, there's probably been about 5 generations of developers that have been working on this project. So along the way, knowledge just gets lost, and you have to relearn that. You're constantly having to reread the code base and understand, what does this do? Is it dead? Can it be replaced? Is it duplicate? And these are all vectors for people to make incorrect assumptions. And then that leads to the types of problems like the failures that you're
Is your on-ramp not some form of digital human COBOL engineer, where you create a customized language model of all of the IBM Red Books, of all of the knowledge bases, so you create a digital human representation to sit alongside these teams and support the management and ongoing maintenance? Because then you're getting, without disrupting, and without displacing, and without transforming, you're just you're giving the customer this highly valuable digital instantiation of knowledge and capability and speed of response that sits within that COBOL engineering team. Then ultimately, as you see the same queries coming in, the same problems happening, then there's an opportunity to potentially modernize sections of the work. Is that a different way? Because I'm trying to solve for this fear of AI people have, fear of breaking things, fear of uncertainty. Is AI going to come in as digital humans in parallel to teams and over time isolate workloads and do it itself?
I think the reality is there's certain teams have a big aversion to any sort of modernization. And
because it's fundamentally their own obsolescence that they're going to resist.
Turkeys voting for Christmas is one of the pushback that we hear. But also they've heard it before, right?
5 times.
5 times, as you said at the start. So they're a bit skeptical because, how much time should I really invest in understanding this technology because, yeah, they've been there before. So that's like one of the challenges that we face with really speaking and thinking about this as a product for mainframe teams, is that often they don't really want to talk to us. And the initiatives around modernization are coming at a kind of higher level where maybe you're involving the cloud team, maybe it's actually an external SI that's being brought in, to actually do this work. And the team is not involved, really that much beyond describing how the original system operates and things around deployment and integration. So, and if you think about the value of a tool that can modernize versus the value of a tool that can just understand, like there's not really a massive market for mainframe COBOL understanding on its own without then going into the modernization part. And, I think it's always a bit of a failure mode in startups to say, this is a bit of a generalization, but certainly for, I guess, startups in our position, you never really want to say, well, we're going to do A, B, and C. C is the exciting thing, but we've got to do A and B first. Like, it's actually much, because you might get to C and realize actually, like, that assumption was wrong, and then you've wasted 4 years of your life. So we just wanted to get on to the valuable part, which is the modernization, immediately. And so that's what we started working on, and we're already seeing traction with.
Tell me a little bit more about that. You were saying there's something you've built that's got virality. Is that within this domain of?
Well, this is this is going to get a bit technical now, but essentially there are two ways to modernize legacy applications. The first is we go from legacy language, so let's say COBOL, to the modern language directly with no kind of intermediary representation. And the other way you can do it is go legacy language to English or just any natural language. Basically describe all of the programs as in terms of a bit like a black box, like what goes in, what goes out, what are the key processing functions, and then based on that synthesize a new application based on the natural language description. And what we're finding is actually that second route is getting a lot of traction with customers. We offer both, and we, for certain projects with COBOL, it actually might be preferable to do the first because these systems are subsystems of subsystems, and you don't really want to change any of the functionality. But for especially online systems, for example, it's very helpful to be able to explain what this does to somebody who's actually used that application. So if it's a risk and compliance platform, then you might bring in some of the users of that platform, show them the English, the natural language descriptions, and ask them, okay, well, what should we add and remove? Oh, you've never used that. Well, let's get rid of that. And then when you synthesize the new application, it's like a reimagining. It's a refactor. It gives you, all the new functionality that people wanted.
That sounds magnificent, Louis.
Yes.
That sounds. You are probably thinking, I've already made this leap. I don't need to do this.
Yeah.
Because you're already in the future. Whereas to me, normalizing a complex legacy architecture into a understandable, accessible, transparent framework based on language. And if that then gives you this key code to be able to push it into any forward language, that sounds amazing. Because what you're essentially giving the customer is transparency and understanding of their own estate.
Yeah.
Which, there you go. And now they have that. The ability to use that then forward transform or build in parallel or whatever, I think is huge.
Yeah, it's massive and it's necessary. I mean, the stakeholders that are involved in a project like, turning off the mainframe, it's just a necessary requirement. Is something we've learned as well.
So can I ask you? You analyze the COBOL code and turn it into a story.
Yes. Exactly. Yeah, we call them processes.
I can see the application of that against government being hugely valuable because there's a lot of complex government process and infrastructure that I don't think anybody really understands. Yeah. Do you know what? I learned this thing. I bought this house once, and what I realised about houses that have existed for hundreds of years is that the original architect and designer created maybe a little niche and planted some trees. And that little area is perfect for breakfast in the morning because the way the sun comes up, because of the way it reflects. The trees are obviously a little bit younger, grow bigger. There's a little gap. It was planted with a few. I mean, if you look at some of the great Victorian garden designers, they had this phenomenal vision because they never saw their vision. Capability Brown and this sort of thing. I mean, you should study. I believe everybody should study this because they have a vision that they never see in their lives, but they plant and they plant trees and they plant things, design gardens. But as these properties, so that original vision of requirement and sitting there and having your breakfast there, as the generations pass, it gets lost. And people forget why that little thing was there and they ended up just, flattening it and putting a big concrete block in, and then have a problem with heat because that's what but if you could somehow reimagine and reconnect with the seeding vision of why these architectures were built, it actually gives you the foundation to build something better and not make mistakes that were avoided the first time. So this idea of somehow capturing architecture and the reasons behind decisions that made to build that architecture actually hugely de-risk any forward architecture. Yeah. But they're lost. They're lost through brain drain out of the organization, people leaving, documentation getting lost, and finding those original trigger reasons on why decisions were made, I think is hugely valuable to an organization. Because one of the reasons people won't want to change things is because they're worried that they don't understand it well enough to make a change to it.
Yeah, 100%. And, we're moving into an era where you can actually kind of move things, in a way that is, you don't really accumulate like as much debt as you previously would have done in the past. Like legacy modernization always meant basically some emulation of a mainframe in the cloud or something like that. And so you have you're trying to shoehorn these new ideas kind of onto the old ideas, and you end up with a compromise. And what you have now is not, it's not a magic button you can press that'll move any system to any system, but it's certainly getting to a point where you would almost have no idea that this application ever ran on a mainframe post conversion. So maybe link this back to your analogy. I mean, you sit there and somebody 200 years ago made a decision, but if you want to change that decision, you can pick that tree up and move it now and rearrange it back if you want to and whatever, in a way that has never really been possible before AI. So that's the big shift. The switching cost has massively decreased, and that is tied to the risk of doing this. And that therefore means you end up with a clean new infrastructure rather than an emulation of the old one. And the two concepts often clash.
Fascinating, Louis. Louis, you've mentioned something that I'm desperate to understand better. Technical debt. In the olden days, last year, where you had, even when you moved to, monthly sprints, quarterly releases, technical debt was managed by the rate of new. If you're not releasing new all the time, technical debt is a function of how quickly you're shipping, really. So is it, how these days, as a startup, do you make decisions on code, on architecture, that means you're building something that isn't immediately obsolete within 12 months? How do you manage technical debt when everything's moving so quickly?
Well, I mean, internally for us or for our customers?
Just how do you personally address it?
So I think about what our startup has not as the IP of all of the software that we built, but the fact that we are a team that really understands this problem and is going to continue pushing whatever the state of the art is into production to serve our customers. And so, we always have this this kind of debate around white labeling our software, for example, so giving it to consultants who could then run with it. And the problem is the software without the team is kind of useless because it's stuck in a moment in time, and then next month or next week a new model is going to be released, and you need our team to then go and do the work to kind of bring it up to speed again. So that's kind of how I think about it. Is team is much more important. It's never going to be the case that you just buy a software product, off the shelf for the next couple of years. Anyway, you're going to buy the software product and the resources to update that software product, kind of at least until AI cools down a bit.
Well, this goes back to our SaaS discussion and Palantir model, COBOL. So you've encapsulated value in the team.
Absolutely.
How do you keep them motivated on long projects? Because what I know is I look at my kids and I look at people's attention span. A mainframe project could be a 7 to 10 year project. Having sustained, consistent work, building trust, opening up opportunity, being there, being present over an extended period can be a challenge in itself.
Yeah, but there's massive novelty in a lot of the work we do, because it's constantly, like every time we solve a problem related to COBOL and Java using AI, like this is something nobody else has done before. So it's really a research project. It's not like the work that we're doing is sitting there and moving logic from A to B. It's more like, we're trying 10 different things out, almost as researchers, but at the applied level, and seeing what sticks, and building these kind of pipelines at a layer above, the actual conversion of those projects. And there's incredible amount of novelty every time a new release comes out or something like that we've got to test.
Tell me what you think. Quantum is emerging.
Yeah.
And when I look at quantum, it feels a little bit like highly proprietary, hyper-consolidated. It feels a little bit like mainframe 2.
Yeah.
This is not a scale-out, decentralized, open system. It requires deep physical control to get trusted, reliable operation. And these are highly capex systems that have amazing potential. But I see it very much as the antithesis of what seems to be happening in warfare and war technology with drones and decentralization, cheap components, throwing them into the battlefield. Quantum is almost going against that narrative.
Yeah.
Could quantum make your ideas obsolete as customers move from mainframe to quantum? Or am I not quite catching?
Yeah, I mean, to be honest, I think you probably know more about quantum than I do. I don't think about it at all. And it's probably the right thing. So maybe having gone through the journey of building an AI company pre the ChatGPT moment, where 2021, even pre GitHub Copilot, pre GPT-3, we were literally training our own models. Like that's what the company was founded to do, and then has kind of morphed into the what it is today through adapting to the changing environment. I would look at that and say, I wouldn't think about quantum until it's happened, unless you're maybe think about Bitcoin development. Then you should probably think about it. But for me, how do I apply quantum to legacy application? Well, let's wait for quantum to have its ChatGPT moment, and then we can talk. Because to be honest, everything else is going to be written off.
Louis, you've totally won me over today. Your ability to articulate this bridge between the existing and a new world, you're doing in a way that it's not driven by ego, or it's driven in a very pragmatic, respectful way, which I've enjoyed, and I've actually taken a degree of stability from the way you're approaching this. This isn't, I had this perception that maybe this is a YC playbook being applied to an industry that hasn't been touched for decades. It's low-hanging fruit for the YC algorithm, whereas actually you're approaching it with a very human-orientated, respectful approach, including you see your own team as this encapsulation of knowledge that is being pointed at novel problems with the customer at the very forefront of your thinking. But that experience and knowledge, yes, you may create technical debt, but you will capture that experience in the team and you will build on that going forward. I think it's a very beautiful vision that you have, and you seem to be executing in a very articulate and very clear way. AI is coming through like a freight train. There's so many people an AI expert, I think people are frightened enough to want to be part of this wave. Whether they're surfing on it or crashing under it, I don't know. We're all maybe doing a bit of that. But Louis, do you think AI is going to take us to a utopia or dystopia?
I think almost certainly a bit of both. So there's this meme, feel the AGI, right? Which I never really understood until quite recently. And I think, I realized, at some point that more than half of my code is now written by AI, not in the Copilot sense, but in an agentic sense, using tools like Claude Code, Codex, etc. And that's literally, doing the work that I did. And I think it took that happening for me to really kind of start to feel existential about this. And so I've been having a lot more of these thoughts about, the potential, especially the dystopia. And you look at like self-driving cars, and 10% of US jobs are in transportation, and you kind of wonder like, okay, well, maybe that could be slowed down by the government. But then you look at a lot of internet jobs or things that just happen through screens, and there isn't really a way for government to turn the faucet on and off of that. That's going to disrupt software developers as fast as the technology is developing. If the government wants to keep software developers employed, there's nothing they can do to regulate that. So I don't know what the answer is, but I certainly feel a kind of sense of anxiety for anybody joining the workforce in 5 years' time, maybe even sooner, depending on how quickly things develop. At the same time as that, I'm very excited to live to 200 years old because of all of the breakthroughs that are going to happen, because this thing can just work faster than all of us. So a bit of both.
We are in a computer game.